I'm here with Robert Pickle, who's one of our robotics controllers who's going to be working with the RRM mission. Robert, thanks so much for being here with me today. First off, tell us a little bit about RRM, this Robotic Refueling Mission. What are you guys hoping to accomplish with this?
Sure. So this is a Goddard developed payload, and their ultimate goal is to do satellite servicing missions. What this payload is it's on the ISS, and they utilize the robotic components that are already up there, the SSRMS and SPDM, and they built a bunch of task-specific tools and adapters, and have interfaces similar to what is found on satellites. And so we've done over the course of the last couple of years multiple tasks. What we have coming up are some of the finer tasks. So for this payload, for the tasks we have coming up, they have a tool specific for cutting wires and actually cutting MLI tape. And what MLI is basically thermal blanketing on a bunch of payloads. And they have basically torque set screws, just like a regular screw you would see, and then they have essentially a screwdriver. And we're going to unthread some screws, both caged and uncaged, and caged being that they can put a cage around the screws and unthread them in space so they can float around and not escape, and then uncaged if they're not covered.
Okay. And you first, just getting back real quick, you mentioned a wire cutter tool, screws, a lot of this stuff. You know, it's my understanding satellites aren't really made to be refueled. Is that correct?
That is correct. So in the future, their goal is, once they get into the servicing business, they'll build the satellites to be more compatible. What they built these tools is to actually do tasks that weren't necessarily originally designed to be compatible with robots.
Okay. All right. And what are some of the specific tasks you guys are looking to accomplish this week?
This week, like I was saying, we're going to cut and manipulate some MLI. And then also they have some MLI that's Velcro down. We're going to grab and manipulate. We're going to unthread some screws. And they have an array bed of essentially coaxial connectors. And we're going to go remove some of these coaxial connectors. And on satellites, what this is basically their little test bed that they could connect up and run some diagnostic tests on the satellites.
Okay. And as a robotics controller here in Mission Control Houston, you're going to be controlling all of that.
That's correct. So we'll be controlling the SSRMS, which is essentially a 56-foot long manipulator, and which is holding the SPDM.
Pretty big arm.
Yeah, which is essentially those two things combined makes it about 70 feet long, and we'll be grabbing tools and then adapters and doing the fine task of basically unthreading a screwdriver from 70 feet away from where your base is.
Wow. And all that from 250 miles down here on the ground.
That's correct.
Very exciting stuff. So I mean, real quick, what kind of, I don't want to try and get too technical, but what kind of interface do you guys have with this? Do you have like a camera system on there? How exactly do you control this arm?
Sure. So on the space station, there's multiple external cameras, and then on the MSS, the SSRMS and SPDM, we have multiple cameras as well. And then when Goddard designed these tools, what they also did was put two cameras 90 degrees apart on each tool, which is basically looking directly at the work site area of the task we're going to be doing.
Okay.
So we'll be using ISS assets and looking at 3 or 4 views at a time and doing the tasks.
Plenty of eyes on everything you're doing at all times. Okay, very cool. After you guys get this done, what are some of the future tasks that are coming up soon on the horizon for RRM?
Sure. So I'll back up and tell you what we've done in the past so far.
Okay.
So this payload was built, and they're calling it RRM Phase 1. And what we've done thus far is we've went in and gathered imagery, flying in at different rates and different distances, looking at features that they integrated onto this payload that they'll post-process on the ground, and hopefully one day have vision algorithms that will help them rendezvous with satellites. In addition to that, there's a coolant valve panel that apparently a similar coolant valve panel is found on current existing legacy satellites orbiting Earth. And we went and removed some valves and caps and manipulated plugs. And then there's a fill drain valve, a common fill drain valve found on a lot of satellites that are on orbit. And we went and cut wires, removed caps, and actually they have a tool on this payload that flows fuel. So we removed the tool, similar to what you see at a gas station. We removed the tool, it has a hose connected to it, connected up to the fill drain valve, and flowed ethanol.
So you guys have actually refueled this payload?
Yes.
Very exciting.
So. And for the future, Phase 2, they have a whole new set of objectives, set of adapters and everything.
Robert, thanks so much for giving us a look inside what you guys are doing here. We'll be sure to check it out.
All right, thank you.
Thank you.